They don't have to be very good spot welds either. Well, I won't say not very good. They don't have to be super huge welds either. Just a good little tack to the point where you know you're getting the metal to melt together is it. You don't want to weld everything solid because you gotta cut it all apart anyway. It doesn't take a lot to keep that motor in place. If you noticed in the other part of the video, I was showing the pressure gauge. You know, we're only hitting like what? 100, 200 psi, something like that. That is it. You're not fighting very much torque on that at all. It's amazing. A few little tack welds is all it takes. Also, be conscious of where you put your tacks. Remember, you need the grinder wheel to fit in there and cut it off. So, you know, if you put it on the back side of a strap where you can't get a grinder, you're going to have a heck of a time breaking that tack back off of there. And we'll loosen up these collars. And hopefully pull the boring bar out. No! Or not. Now one of the bearings is cockeyed just a little bit, got some pressure on it. That's what happened to me last time too when I was setting up. Oh. Alright. Go find my brass hammer and just tap on these bearings a little bit and try to get that bearing to self-align a little bit more, and then the bar should slide right out. Yep, there it goes. Easy as that. Well, on this end of the housing, I have a slight problem with my boring bar. I think it settled down on me a little bit. It is so hard to tell, and I can't get the camera at the right angle. But can you see that bit is below the chamfer of the hole? Let's see there. Can you see that? And if I go down below it, so from underneath here you can see a lot better that the bit is inside the chamfer on the top and outside the chamfer on the bottom. So I need to raise the bar up just a little bit. I think. I don't know, I was trying to figure out how critical it is because it's a few thousandths. I mean, it's enough that you can see it. And I'm going to assume that that chamfer was made on center, but I suppose it may not have been. But I think is what was happening is since that hole was chamfered that much, that my centering cone was riding on the bottom of the hole and into the chamfer on top, so it wasn't up high enough. I'm just going to flip that bearing to the outside, and then I might be able to bring it up in those holes quite a bit. So I'll try that. Okay. Well, flipping it over actually didn't work. Matter of fact, it made things worse. And if I would have thought about that a little bit, I would have realized that. Because we are farther away from the point that we want to move, which means it has to move further. Farther. The other word. So, I still went out here. That way the bearing could move inside the channel. And then I put 3/8 bolts in it instead of the 7/16 bolts that were in it. And that was just enough. I got it clear up the top of those bolt holes. And if you can see this, that is hitting the top of the chamfer there. And on the shadow side, we're not quite out to the edge of the key. So I'll do a little measuring with the calipers, and then I'll set the motor on here and get it set up, and we'll be ready to rock. Or bore. that test cut, oh, shouldn't have turned that backwards. You can kind of see about how big you're getting. And that's the setup I came up with this time. Just put all the angle irons like that. Lead screw or whatever you want to call it underneath this time. I think we're ready to go. If I keep doing line boring stuff, which I'd like to do more of it, I really should make a nice carriage. But I really don't think I'll be using this motor either because it's too slow for a lot of applications. So I guess there's no reason to for this one. Okay, there's enough there. I'm going to try to measure that, just see where we're at. I don't know if those are... it's going to be off a little bit that way, but... Well, that's what it's telling me. I don't know if that's true. It might be a little bigger than that. Yeah, it's darn close eyeballing it that way, so... Definitely in the ballpark of what I want, and it looks like we're completely cutting out the key. So we'll keep going. You get me a foot pedal for this power pack, that way I can stand on it like a dead man switch. You see that? The housing raised up just a little bit there. Too much pressure on it. I wonder if I need to clamp it down a little bit better. I'll go find a big clamp and stick on there. Put my big Bessie clamp on it. Help with a little bit more downforce. So we'll see if we can go back to boring. That's still raising up just a little bit. I've decided I'm going to spot weld this triangle piece right back here to the table. The scrap piece of flat I had wasn't quite long enough, so I had another block laying there. So I'll spot this up here. Well, I guess tack is the more technical term. Tack it up here, tack it to the block, and then tack it to the table. These chips coming out of this triangle piece, where I'm actually boring, are pretty soft. I was playing with them. They seem like actual steel. So I took the hand grinder and touched this triangle piece, and the sparks went clear to the ceiling. They are insanely long. So that's not hardened. So that's not high carbon steel. So I'll be okay spot welding to that. And then, since I was grinding, I decided to hit this with the grinder right over here on this corner, and the sparks only went about that far and just flowered out everywhere. So this definitely is high carbon. So I'll be okay spot welding to that piece right there. So I'll do that and we'll get back to boring. Put you over here, that way we can see if the housing is going up and down or not. I can't make up my mind for where I'm looking because I think the top of this channel iron might be moving and it makes it look like the housing is moving. So I'm going to go grab the dial indicator. I think you can see the needle from there. And we'll go ahead and set it to 0-ish. Can't tell how much that's vibration and how much that's the needle actually moving. I just realized since this is not cast iron, you need to add some lubricant. There is significantly less chatter in there. Running much better. Doesn't that sound a lot better? Oh, I have to take a little bit of a break. This is way too slow of an RPM for this, for steel. I don't mind going this slow in cast iron. It actually worked really well in cast iron. But in just regular steel, this is way too slow. Oh, it's taking forever. Take both out, do I? Silly me. Alright, let's take that one off. Woo! Wowzers. Woo! Yeah, downright warm. Okay. Let's see here. Actually, you know what? Going the other way might make more sense because I can pull it clear through until it hits up here. There we go. Now I can check that bore. There's a ring right there. I can feel the telescoping gauge catch. Darn it. Alright, that's probably a really crappy reading too. 1.742. I'm going to make a little adapter. I had an idea that this is the coupler, whatever you want to call it, that goes from the end shaft of my boring bar to the 7/8 shaft of the hydraulic motor. And it dawned on me overnight that if I made another adapter to go from 7/8 to 1/2 inch, I could use an electric drill to power this thing. I'm going to use an electric drill to power it to finish up this project because I want to see if I can get out those ridges that are in that bore that we just did. I don't like them. They're about 3/1000 tall, and when I stuck the boring bar in there and turned it by hand, it actually started cutting again in those places. So I think if I use a high-speed drill. Well, not even high-speed. Like, I guess as far as drills go, it'd be a low-speed drill, like a 500 RPM drill or something, and then just push it through by hand. I can get a lot better finish in that last bore. Yeah, works that way. I don't know why I didn't go the other way. Huh. Yep. I did this collar in the drill press, so I'm going to blame it on this collar being slightly off. But hey, it fits that way perfectly, so good enough, right? Okay, I'll part that off and we'll go back to boring. I need to watch my fingers on that side. Okay. Wow. It's a little fast. 800 RPM is just a bit fast. I wanted to use my 500 RPM drill, but I forgot the handle cracked on it. I don't trust it. So 800 it is. Definitely removing some in there. So on and so forth. But obviously it's working pretty darn good. I definitely removed some metal in a few places. There's a couple times there were some really good chips being flung out of there. So I went over it 5 or 6 times. You know, first time really slow, and then pulled back really slow, and then just kind of went in and out at a good pace a couple times, trying to figure out if there were any high spots, and it doesn't catch anywhere in there now, so I'm going to say that's probably a really, really good bore. That is a really, really nice finish. I don't feel any high spots anymore in there, and what little I can see in there, it looks pretty good too. This is my go, no-go gauge I made for when I was rebuilding the Tulsa winch. I was actually going to weld that thing up and bore it back down, so I made this gauge. It's 5 thousandths under 1 3/4. Bouncing around 744. So it should slide in here now. Hopefully I'm a little under 1 3/4. Oh yeah, that slides easy. That's pretty darn nice. So that tells me I am definitely where I want to be. I need to switch over to this project for a little bit. Had this shaft show up. It's very bent. I think you can probably tell there in the camera that it's very bent. So my 1-inch shaft has showed up. That's something I cannot keep enough of in stock, is 1-inch cold roll. Man, I constantly use that stuff. And the bearings showed up too, so I've got to get on this project and get this done for the guy. And then I've got to figure out how to weld this hitch. He brought this along, but that is definitely cast iron. So I am debating about what to do to weld that all together. Got a few ideas, but not sure. I'm going to do this, and then when I get this all done, we will get back to the tractor. I'd like to show you all a trick real quick since I'm working on this project. This U-joint is stuck on the end of the shaft really good. They welded it on there. So I've cut through the weld, and you obviously can't press it out without taking the U-joint apart. I really don't want to do that on this old U-joint. I'm sure if I greased it and took my time, I probably could get those snap rings out of there. I probably could get it all pressed apart, but it's going to be tough. If you ever worked on an old rusty U-joint, you know what it's like getting those boogers apart. They might not even come apart in one piece. I might end up tearing something up. So, I had to get this bearing off right here, so I cut the shaft there. So it's a little short, so I put a little bit of all thread on there. And the reason for putting the all thread on there, and one of the reasons I really like this old Owatonna press, or however you say it, let's just say OTC. If you take out the threaded rod that normally pushes things out, you have a hollow cylinder. Okay, an hour later I'll have this tightened up on there. Alright, so cinch that thing on there like that, and hopefully oh yeah, it won't fall down. Because of the threads in there, the 1-inch shaft won't go all the way through. But anyway, it's apart. Super easy. That was a whole lot faster than taking apart that thing. Well, it's Monday, so I guess that means putting our hat back on and getting back to work, right? Drop my hat. Can't believe I'm always dropping my hat these days. Alright, now let's get to work. I gotta tear this off. Let's see here. I don't know what I'm doing. I haven't worked on it in a couple days because of the weekend, so I'm a little confused as to where I'm at right now. So, pull the boring bar out. There we go. And I don't want that over here. And let's see, what all do I need to do here? I think I'll just take off this front rig, leave the thing on the table just in case I need to put it back together for some odd reason. Oh, something else I need to do is I cannot see in when I use this big channel iron. I like this big channel iron. I think I want to keep using it for different, for line boring like this. but I need to drill a big hole on each side of this bearing. Matter of fact, what I think I might do is just do the same hole pattern I did here behind this bearing and put one over here and one over here, you know, one on each side of the bearing. That way I can see through and see what the heck's going on there, because it's too difficult to see over or under that thing. Alright, so I'll tear down all this front assembly, and then I think I'm going to make this bushing in here first. I want to measure in here really good now that I can actually get access to it. So we'll just start with a general measurement of the calipers, and that is 751. Make sure we're on 0 here. Yep. So that's claiming to be 751. Darn it. Let me grab my chunk of shaft that's actually 1 3/4 and see if it fits in there. Okay, see if this fits. I haven't tried it. Hopefully it doesn't, but nope. You know what? I about decided that my calipers are getting a little bit of wear to them in the inside, and I guess it'd be, yeah, inside and outside do not agree anymore. So that would almost be a perfect fit. That would be hard steel, wouldn't it, using a hydraulic rod? Was that stuff considered chromoly? Is that what it is? Whew. That'd be a heck of a way of doing it. I wonder if I get that to press in there. It's starting though, isn't it? After getting some really odd readings in here, I decided I better go through with the hone for a little while. I just figured there had to be a ridge or something in there. And I can see a couple actually divots where it looks like the bit dug in a couple places, so I've been trying to avoid taking readings there. But if I take a reading vertically, I get basically 749 or 748.5 right there. And then if I take one horizontally, 749. Okay, so I keep getting 749 in there. I think that's right. Feels pretty darn good. Might be a spot right over there I don't like, but so I think I'm going to call it 749, and I'm pretty sure this will work. I think I can get that pushed in there. So I'm going to go anneal this, and we'll go stick it in the lathe and see if we can't put a hole through it.